Okay, today we continue our study of matrices, and we are on notes number 13. Last time we learned what a matrix was and how to do some basic operations with matrices, and today we're going to start getting into some of the applications. We're going to learn about something called a determinant, and then we're going to learn a method that is used to solve a system of equations, and that method is called Cramer's rule. So first of all, I'm going to present to you the concept of a determinant, and it's going to feel kind of just abstract and out of the blue and like, what's the point of just doing this and why do we need it? But as we look at some applications, you'll see how it comes into play. So a determinant is notated with the letters D, E, T. So if you want the determinant of matrix A, you could say determinant of A in this way, or you could use straight bars around the letter A, and the straight bars instead of the square brackets indicate determinant. Okay, or if you know the elements of the matrix, like if the matrix has elements A, B, C, and D, you can just put the determinant around the elements, put the straight lines around the elements themselves like that. And that also means determinant. So how do we find a 2 by 2 determinant? What's the determinant of the matrix with elements A, B, C, and D? What we do is we find the product of the numbers on the main diagonal. The main diagonal is this one. So that product is A times D. And then we subtract the product of the numbers on the other diagonal. And so that would be subtracting B times C. So the number you get when you take A times D minus B times C is the determinant of a 2 by 2 matrix. You can only find the determinant of a square matrix, 2 by 2, 3 by 3, etc. So let's practice. Let's say matrix A has elements 6, -1, 2, -4, so it's 2 by 2, and we're going to find the determinant of matrix A. So that would be what you get when you multiply 6 by -4 minus 2 times -1. So 6 times -4 minus 2 times -1. So that would be -24 plus 2, so that would be -22. What does that mean? How does that help anything? Well, we don't know yet, but we're going to get to some examples where determinants are actually used to help calculate something. First, I want to show you how to find the determinant of a 3 by 3 matrix. So let's say that our matrix has elements A, B, C, D, E, F, G, H, I. I almost forgot my alphabet there for a second. I had to stop and think. Okay, this is significantly more complicated than the 2 by 2. That's going to be kind of the pattern here. When we do a 2 by 2, simple. 3 by 3, much more complicated. 4 by 4, way more complicated. And you should know that matrices are really great for large systems. 3 by 3, 4 by 4, 10 by 10, 100 by 100, but we would rely on computer systems to work with larger determinants, and we're just working with small ones so that we can understand the ideas behind them without killing ourselves in the process of doing all that work. Okay, so here there are several techniques for finding a 3 by 3 determinant. I'm going to show you my favorite. The first thing we do is we rewrite the first column outside the matrix, and we rewrite the second column as well. This allows us to have 3 diagonals that have 3 elements each. So the main diagonal, A, E, I, we're going to multiply those. We're also going to multiply the numbers on the next diagonal going the same direction. And we're going to multiply the numbers on the next diagonal going the same direction. And we're going to add those products together. So we have A times E times I plus B times F times G plus C times D times H. Okay, after that, we go with the diagonals that go the other way. And we're going to subtract all of their products. So the diagonals going the other way would be C, E, G, A, F, H, B, D, I. B, D, I. So we have subtracting the product C, E, G, subtracting the product A, F, H, subtracting the product B, D, I. Now instead of writing it that way, we could show that we're adding the first 3 products together and then factor out the minus and add the last 3 products together and just subtract that final sum. So you can look at it either way. Subtract individually or add the 3 together and subtract all at once. So let's try this. Find the determinant of the 3 by 3 matrix. So the first thing we want to do is rewrite the first column 4, 1, 2, and the second column -2, 1, 5, so that we have diagonals that have 3 elements each. So we're going to multiply these numbers, and multiply these numbers. So that gives us 4 times 1 times 3, 12, plus -2 times -2 times 2, 8, plus 0 times 1 times 5, 0. I love the number 0 when it comes to matrices. It's so great. Now we're going to subtract the other 3 products. So we would have 0, 1, and 2. We would have 4, -2, and 5. We would have -2, 1, and 3. So that would be 0 plus -40 plus -6. So we have 20 minus -46. So that gives us 66. That's the determinant of that matrix. Okay, so here is one of the applications of determinants. And please don't write what you're about to see. I'm going to show you the proof. I know you miss proofs from geometry, so every once in a while I'm going to throw in a proof. So please don't write the proof. You'll just write the conclusion when we get to the end. Here's a way you can find the area of a triangle. I've written it all out ahead of time so that it can save us time. So let's say we want to find the area of a triangle and we know its vertices. Its vertices are x1, y1, x2, y2, and x3, y3. I decided I would plot them on a plane, and I put an x-axis in there. I didn't put a y-axis. It's not really necessary. So I just plotted those 3 points. And then what I did was I dropped a perpendicular from each of the points down to the x-axis. And that way we have created a couple of trapezoids, actually 3 trapezoids, 1 large one and 2 small ones. The large one encompasses the triangle and the 2 small ones. And I also wrote the coordinates of the points at the bottom. So because this point had an x-coordinate of x1, the point down here is x1, 0. This point had an x-coordinate of x2, so this is x2, 0, etc. x3, so this is x3, 0. Okay, so we're just getting set up now. Here's the picture again. And what we want is the area of the triangle. So the plan is to get the area of the triangle, you would take the total area of the large trapezoid and subtract the areas of the 2 small trapezoids, trapezoids 1 and 2. How do you get the area of a trapezoid? Remember the formula for the area of a trapezoid? You take 1/2 times the height times the sum of the bases. And in this case, these trapezoids are kind of sideways, so like the height, that would be the height of trapezoid 1. This would be the height of trapezoid 2. Add those together, you get the height of trapezoid 3. And then for trapezoid 1, this is a base and this is a base. For trapezoid 2, this is a base and this is a base. And for the big one, this is a base and this is a base. Okay, so the computations. All right, so I used the formula for the area of a trapezoid and found the area of the big trapezoid minus the area of one of the small ones minus the area of the other small one. And you can pause if you want to look back at the figure and make sure that that makes sense. Some of you are interested, some of you not so much. What I did next was I multiplied using the FOIL technique, multiplied these 2 binomials together, and that gave me this. I multiplied these 2 binomials together, and that gave me this. I multiplied these 2 binomials together, and that gave me this. And because there was a 1/2 in front of all of them, I factored out the 1/2. Okay, then I distributed the negative signs. We had one here and here. and then combine like terms. And notice what we have now. We go back to a larger view. What we have now is a number times 3 products minus 3 products. Does that ring a bell? 3 products minus 3 products. Just like a 3 by 3 determinant. 3 products minus 3 products. Now it just so happens that in this area formula, each of these products only has 2 numbers. Well, we can fix that. Let's multiply them all by 1. Now they all have 3 numbers. Okay, so we have a product of 3 numbers plus a product of 3 numbers plus a product of 3 numbers minus that. Okay, so we really have a 3 by 3 determinant. And if I write it back in its matrix form, if you think about it, 1 times x1 times y2, those 3 numbers could go on the first diagonal. 1 times x2 times y3, those numbers would go on the next diagonal. I would have to write the extra columns out if we wanted to thoroughly investigate that. Okay, now, this is the area of the triangle. However, if I write the points in a different order, if I rearrange the rows in a 3 by 3 matrix, the determinant might end up negative instead of positive. So if I take the determinant of x2, y2, 1, x3, y3, 1, x1, y1, 1, that might be the opposite of the original, or it might be the same. I just don't know. Sometimes you get the opposite, sometimes you get the same. So we need area to always be positive. So, well, what do we normally do to make something always positive? We normally take the absolute value. What symbol do we use for absolute value? Straight lines. Well, that's a problem because we're using straight lines to stand for determinant. So the workaround for this, it's not the best ever, but what we do is we say the area, and this is what you want to write. The area of a triangle with vertices x1, y1, x2, y2, x3, y3 is plus or minus 1/2. Okay, the plus or minus is how we compensate for needing it to always be positive. If the determinant is negative, multiply by negative 1/2 to make it positive. If the determinant is positive, multiply by positive 1/2 to make it positive. So one or the other, not both. To get a positive area. And it is that determinant where you have the first vertex with a 1 after it, the second vertex with a 1 after it, and the third vertex with a 1 after it. The 1s just allow you to have a square matrix. And multiplying by 1 does not change the value of anything. Okay. So let's apply that to this problem. The approximate coordinates in miles of a triangular region representing a city and its suburbs are 10, 20, -8, 5, and -4, -5. Find the area of the region. All right, so let's set it up. We have the area is equal to plus or minus, we'll figure out at the end which one it is, 1/2 times the determinant of the matrix with elements 10, 20, and 1, -8, 5, and 1, -4, -5, and 1. Okay, I'm going to show you doing this by hand, and then I'm also going to show you with a calculator. So let's rewrite that first column and that second column. Sometimes people go through this process and they forget about the 1/2 or the plus or minus, so we'll try to remember to keep that all along the way. Okay, I'm just using my bracket to stand for parentheses. Maybe that was a bad idea. I'll put parentheses instead. Okay, so the first diagonal, 10 times 5 times 1, that's 50, plus The next diagonal, 20 times 1 times negative 4, that's negative 80, plus the next diagonal, 1 times negative 8 times negative 5, that's 40. Now we're going to subtract, and then from the other diagonals we have 1 times 5 times negative 4, that's negative 20. Ten times 1 times negative 5, that's negative 50. 20 times negative 8 times 1, that's negative 160. So we have plus or minus 1/2 times 10 minus negative 230, if I did that right. So that would be plus or minus 1/2 times 240. So we want the plus, not the minus, because we want a positive area. So the area is 120, and the units were miles, so 120 square miles. Okay, there is another application that we need to talk about for determinants, but I'm going to leave that for the second video. Oh, real quick, let's look at how to do a determinant on the calculator. So go into the matrix menu, second x to the negative 1. Let's do a 2 by 2 determinant. So notice I already have a 2 by 2 matrix as A. So what we can do is go over to math. Notice what the first choice is. It's determinant. So select that, and then back into the matrix menu, select matrix A. It's going to find the determinant of A, and there we have that number, negative 18. If you want to do a 3 by 3 determinant, which is more likely because 2 by 2s you can do pretty quickly by hand, probably faster than typing in all those numbers, but 3 by 3s are a little bit more involved. So let's go down and let's make matrix C. Let's edit matrix C, let's make it a 3 by 3. Put some numbers in there. Whatever they happen to be, and then back to the home screen, so we quit, and then back into matrix, over to math, choose determinant, back into matrix, go down to letter C, enter, and we get our determinant. Okay, so that's it for this video.